In the first part of this example, we're asked to find the eigenvalues for this given matrix. So to find the eigenvalues for a matrix, we need to look at the characteristic equation, which is the equation determinant of A minus lambda I is equal to 0. That's where you find the eigenvalues for a matrix. So our first order of business would be to actually set up this A minus lambda I matrix, which would be this given matrix minus lambda times the identity matrix of the same size. So this is going to be a 3 by 3 identity matrix. Now notice what that amounts to here is, if we actually multiply lambda times that 3 by 3 identity matrix, you get a matrix with lambdas down the main diagonal and then zeros in every other entry. So when we take the matrix A here and subtract lambda I, we're just going to be subtracting lambda from the diagonal components here. Every other component we're subtracting 0. For example, this position is 1 minus 0, and then -1 minus 0, and then 2 minus 0. So we're only affecting the diagonal entries when we subtract this lambda I matrix. Okay, so I need to be able to see the matrix there. So let me start out writing the determinant here. So the determinant of A minus lambda I is equal to the determinant of, okay, so we're going to subtract lambda from the diagonal entries. So 2 minus lambda, and then the rest of column 1 is unchanged. And then in column 2 we have 1 and then 1 minus lambda on that diagonal entry. And then this last entry is unchanged. And then in the last column, the -1 and the 2 are unchanged, but we just subtract lambda, like I keep saying, along the main diagonal here. Now to find the determinant of this 3 by 3 matrix, we can do the cofactor expansion along any row or any column. Just by the way, using row operations like we did in the last section to find the determinant, to maybe try to make this a triangular matrix, it doesn't go well for this A minus lambda I matrix, because when you're dealing with this variable lambda inside your matrix, it makes it very tricky to perform those row operations. Things get very messy. So you're best off just to go ahead and do the cofactor expansion. If you can pick a row or a column that has a 0, then that's always nice, but this one doesn't have any of those. So I'm just going to expand along the first row, because that tends to be what's just most natural. Don't forget to alternate signs, so that's what I've written there along the top as we do this. So this is equal to positive 2 minus lambda times the determinant of the 2 by 2 when we delete this column and this row, so times this determinant of that 2 by 2. So 1 minus lambda and -1, 2, and 4 minus lambda. Okay, and then we've got a negative here, so -1 times the determinant of the 2 by 2 when we delete this column in the first row. So we're going to have 2, 1, and 2, 4 minus lambda for the columns there. So 2, 1, and 2, 4 minus lambda. Okay. And then in the last position along this column, so we have positive, but then there's a -1. So we have positive -1, which sounds weird, but so we have -1 times the determinant of the 2 by 2 when we delete this column in this row, so times the determinant of this 2 by 2. So that's 2, 1, 1 minus lambda, oops, -1. Okay, now you have to be careful as you work through this. This characteristic polynomial for the 3 by 3 it's going to be a degree 3 polynomial in terms of lambda. So don't charge at this thing full force and just try multiplying everything out all at once. Kind of take your time with this and be looking for common factors, things like that. So I'm going to leave the 2 minus lambda out there for sure. and then work on the determinant of this 2 by 2. So I have this times this. Okay, and I am going to go ahead and multiply that out just so this video isn't 2 hours long. So I'm going to FOIL. Imagine we're foiling 1 minus lambda times 4 minus lambda. So first I have 1 times 4, so that's 4. First, outside I have 1 times negative lambda, so I have negative lambda. Inside I'd have negative lambda times 4, so that's minus 4 lambda. And then last, I'd have negative lambda times negative lambda, so that's positive lambda squared. Oops, and then I forgot. So that's just the a times d part of the determinant. That's just this times this. So then we have minus negative 2 from here. So minus the negative 2, so I'm going to go ahead and write plus 2. Whoa, I did not mean to do that. All right, so we're done with the determinant of that first 2 by 2. And that's going to be the toughest one. We'll start to move a little quicker here because I know this video is already getting long. So I have minus 1 in front of that next determinant. And then when I multiply this out, I'd have 2 times 4 minus lambda. So I'm going to go ahead and multiply that out. So 2 times 4 minus 2 times lambda. And then minus 1 times 2, so minus 2. Okay, and then with that last determinant, so I have this negative 1 out here. And then I have 2 times negative 1, so negative 2. Minus 1 times 1 minus lambda. So be sure it's minus that whole 1 minus lambda. That negative should distribute to both parts here. Okay, so let's see what we have. I'm going to try to write this next step a little smaller so you can see it better. Or in fact, let me do this. I forget about these capabilities here. Okay, so we've got 2 minus lambda, and then inside the brackets here, combining like terms, I have lambda squared, minus lambda minus 4 lambda, so I have minus 5 lambda, and then positive 4, positive 2, so plus 6. And then minus, inside the parentheses here, I have negative 2 lambda and plus 6 when I do 8 minus 2. And then the last one here, when I distribute the negative there, that's a positive lambda minus the negative, so positive lambda. Negative 1 minus 1, so negative 3, minus 3. Okay, let me do one other thing here. So I'm trying to factor things as much as I can because I'm hoping for a common factor. If you just multiply this out, you're going to have a cubic equation, and it's not, I mean, if you can factor by grouping, great, but if you can't, then you end up kind of stuck a lot of times. So if I factor this y squared minus 5y plus 6, that factors as y minus 3, I keep saying y, I'm sorry, lambda, it's upside down y, lambda minus 3, lambda minus 2. Okay, and then, so now I'm starting to notice, well, I've got lambda minus 3 here, and I've got lambda minus 3 over here. So let me inspect this a little more closely with that in mind. If we factor out negative 2 from this right here, so that'll end up, I have a negative in front already, and if I factor out a negative 2, that'll leave me with positive lambda. If I factor a negative 2 off of that plus 6, there'll be minus 3 left. And so now I've got this common factor of lambda minus 3 across the board, so we can factor that out. Lambda minus 3 comes out, and let's see what's left. So what's left is, in the first part, I have 2 minus lambda times lambda minus 2. There. In the second part here, I have plus 2. And in the last part here, I just have a minus 1, because we factored out that lambda minus 3. And so now the characteristic polynomial looks like this. Lambda minus 3. If I multiply these guys out, I'll have negative lambda squared. I am going a little out of order here. I just want to speed this video up. But so I'll have a negative lambda squared, and then as far as how many lambdas, let's see, I'd have 2 lambda, and then here I'd have another positive 2 lambda, so it looks like when you FOIL in the front there, oh man. So I'll have a positive 4 lambda, and then, let's see, so first is 2 lambda, outside is -4, inside is that negative lambda squared, and last is the +2 lambda. Yeah, so we've got everything from the foiling in there. And combine that with +2 -1, so +1. So I'll have to carry this down one more line. Actually, maybe a couple. Okay, so let's see. Lambda -3. Clean this up. Lambda squared +4 lambda. And then -4 +1, so -3. Now we could factor from here, but things are generally easier to factor if you have a positive squared term. So I'm going to factor a negative out of this whole thing and move it to the front here. So I'm going to move a negative out front. I'm leaving the lambda -3 alone. When I factor a negative off of everything in here, I have positive lambda squared, -4 lambda, +3. And so now you want two numbers that multiply to give you +3 and add up to -4. And so that's lambda -3, lambda -1. This is the characteristic polynomial for, well, I mean, actually every line of this. We're just simplifying. But this is the characteristic polynomial for that given matrix A. And from what we're looking at here, and let me write it a little more concisely as lambda -3 squared times lambda -1. Now that we're looking at it here, we can find the eigenvalues by setting the characteristic polynomial equal to 0. And that gives us the result either lambda = 3 or lambda = 1. And these are the eigenvalues for that given matrix. Sorry this video was so long.